All right. Hello, everyone. Good morning, afternoon, evening, depending on the time zone you're in. Welcome to CPPCon 2020. Before I get started, just want to say feel free to visit our table at the Expo Hall to meet the rest of the Microsoft C++ team. At the table, you can ask us any questions and we can discuss the latest announcements. We have some exciting announcements this week. Also, please take our survey. And if you take our survey, you are entered in a raffle and have the chance to win one of 5 copies of Microsoft Flight Simulator. So we'll be giving out a copy each day that the conference is running. All right, so let's get started. My name is Julia. I'm a program manager on the Visual C++ team at Microsoft, and I'm really excited to talk about collaborative C++ development with Visual Studio Code today. Collaborative development has always been a real important scenario, whether you're working with a partner on a school project, contributing to the same code base as a coworker, or contributing to an open source project. But in today's remote world, pair programming has a whole new meaning. You can't just pull a chair up next to your coworker's desk and watch them reproduce an issue on their own machine right in front of you. Now, more than ever, collaborative development relies on being able to easily reproduce issues from one machine to another, making the common problem that your development environment is different from someone else's development environment especially critical. So, reproducing issues from one machine to another can be pretty tough for a number of reasons. To name a few, you could be using different platforms, which involves different operating systems and architectures. You could be using different compilers and debuggers, different build systems, different system libraries and package managers, and some projects have platform-specific dependencies. So I'm going to give you 3 recommendations today to navigate these problems and make remote collaborative development a little bit easier. So the first recommendation is to set your project up for cross-platform development from the start. The second recommendation is remote development containers, which will ensure a consistent development environment from one person to the next and eliminate all the time you spend configuring your project for a specific platform. The third recommendation is to use LiveShare, which enables remote pair programming. All right, let's dive into these. So the first recommendation is to set your project up for cross-platform success from the start. It'll be easier for someone to reproduce your issue and build your project on their machine if you set it up so that it works across platforms from the get-go. There are a few tools that we recommend for cross-platform development. The first that I'll talk about is CMake. CMake is a cross-platform build system generator. What do I mean by build system generator? A build system generator has platform and compiler independent configuration files, and then it invokes your platform's native build tool under the hood. So you could have the same configuration file across Linux, Mac, and Windows. And then, depending on the platform you're using, CMake will invoke Ninja or Makefile under the hood. CMake is open source, and there's a great community around it. And because of its cross platform functionality, it's a super popular choice for open source projects. The next tool I'll talk about is VC Package. VC Package is a cross-platform command line package manager for C++. So we recommend using a language package manager like VC Package as opposed to a system package manager like Brew or apt install. This way, you can set your project up to automatically install dependencies using VC Package, and it'll do that across platforms. You don't need to use a different mechanism to install dependencies depending on what machine you're using. There are over 1,300 libraries in the VC Package catalog across Windows, Linux, and Mac, and they are all routinely tested against each other to ensure a high-quality compatible catalog. You can integrate VC Package with CMake so that CMake can find the libraries that you've installed on your machine using VC Package. And if you add a VC Package manifest file to your project repository that lists its dependencies, CMake and VC Package will work together to automatically install those dependencies when you configure your project for the first time. You don't need to install those dependencies beforehand. All you need to do is have VC Package installed on your machine. Both CMake and VC Package have great integration with Visual Studio Code, which is what I'm going to demo for you today. For those of you who don't know, VS Code is a free cross-platform editor, and it's built on open source. It's customizable from lightweight editor if you want to just open it for quick edits to a full IDE-like experience with build, debug, and remote development support. Okay, let's do the first demo, which will be using CMake tools, which is a CMake extension in VS Code, and VC package. And I will be configuring, building, and debugging OpenRCT2, which is an open source CMake project. I'll do it on my Mac laptop, and then I will quickly SSH into my Linux VM and show you how we can configure and build the same project using VC package, using CMake, just do it the same exact way on my Linux VM. A couple of things that I did before this demo are install Visual Studio Code, which you can do by following the link on the slide. Install a C++ compiler. So GCC, Clang, and MSVC are popular choices. In the demo that I'm doing today, I'll be using Clang because I am building on my Mac OS laptop. I installed the C++ extension pack, which is a new extension pack that bundles together popular extensions that we believe are most helpful for C++ development in Visual Studio Code. All of these extensions that I'll be demoing for you today are included in this extension pack. And lastly, I installed VC Package. All right, so on my machine, I will navigate to my OpenRCT2 project directory and open VS Code. And this is a CMake project, which means it has a CMake list script, and it has a VC package.json manifest file. So let's go ahead and take a look at that VC package.json manifest file, where I list out the VC package libraries that I want to install when I configure this project, such as Jansen, SDL2, etc. So as I mentioned before this demo, I had installed VC package and run the command VC package integrate install. So let me just go ahead and show you what that looks like. Running that command, VC package will tell you what you need to set your CMake toolchain file path to be, such that CMake can find this instance of VC package and the libraries that you installed. So there you see the CMake toolchain file path. And if you're just building with CMake from the command line, you would pass this in as a command line argument. But if you're using CMake tools in VS Code, you just have to set this once in the settings.json file in the .vs code folder for your project. So you can see here I've set CMake toolchain file path to be what VC package told me to set it to when I ran VC package integrate install. So now we have CMake tools set up to work with VC package to install these dependencies and use them when generating IntelliSense for our source files and to build our project. So here's my CMake list script. So this is a script that tells CMake how to build the project. And with the CMake tools extension, you can either create a new CMake project from scratch, turn an existing project into a CMake project, or configure an existing CMake project. Because this project already has a CMake list script in its root directory, we're ready to start configuring our project. So there are two things that you need to do to configure your project. And also you can interact with CMake tools from the status bar with these commands in the blue bar at the bottom, or from the command palette. If you type CMake, all of the commands provided by the CMake tools extension will appear in this dropdown. So there are two things you need to do to configure your project. The first is select a kit, which contains the project agnostic, configuration agnostic build instructions for your program, like the compiler you're using. And that list of compilers was compilers found on my computer from the CMake tools extension. So the selected kit appears in the status bar, and you can click that button to switch the kit if you'd like. You don't need to open it from the command palette. So the second thing you need to do is select a build variant. By default, the CMake tools extension provides 4 build variants, each corresponding to a different build type. So the one that we're going to use today is debug. So once we select the variant, after we've selected the kit, the project will automatically start configuring. There we go. We've had a successful configure, and our build files have been written to our build folder. And you can see in the output that it ran this command running VC package install. So that means that it picked up the VC package manifest file in the root directory and checked to make sure those were installed. And if they weren't installed, then it would have gone ahead and reinstalled those for us. All right, so now we can select our build target. By default, the CMake Tools extension will build all targets, which is what we're going to do today. Then we can click build. All right, so we have a successful build. So we've used VC Package and CMake to configure and build this project in VS Code. So now let's select a target to debug. We'll select Open RCT2. And I actually don't have any breakpoints set at the moment. So this should just launch the game Open RCT2 on my computer. Yep, and there it is. So we've successfully built and run the game. We can go in and select a park and play the game a bit. But the reason I recommended using VC Package and CMake is because of their cross-platform capabilities. So now I want to go ahead and show you how we can connect to a Linux VM and do the same thing, like using VC Package, using CMake, and build and debug the same project on the Linux VM. So if you open the Remote Explorer and then select SSH targets, you'll see these are targets that I've previously connected to using the remote SSH extension in Visual Studio Code. You can add a new target by clicking the plus sign. I'm going to connect to the last one in the list because that's where my open RCT2 project files live. So it's worth calling out that how the remote SSH extension works is that all of these source files actually live on my Linux VM. They are unrelated to files that I have installed on my local machine. So we'll open my project folder on my Linux VM. And here we have our VC package.json manifest file listing our project dependencies. We have our CMake list script. So we should be good to go to start configuring and building our project. And now if I select a kit, these are compilers that are found on the Linux VM itself. So we'll select the compiler we want to use. Then we can select our variant. We'll do debug again. And now it's automatically configuring our project. It's running the VC package install command again on the Linux VM. And our build files have been generated, so we can go ahead and build all targets. We have a successful build. So now let's set a breakpoint and start a debugging session. I'm going to set a breakpoint in the Open RCT2 CLI folder. We'll set one in cli.cpp. Cool. And now let's debug the Open RCT2 CLI target. So I'm debugging this target because I'm running this headless on my Linux VM. And now CMake Tools is launching the debugger in VS Code. And if we look at the debug console output, you'll see that it's using GDB on my Ubuntu Linux VM. So you can step through the program just as you would on Mac OS. And you basically, the remote SSH extension allows you to have the full feature set of VS Code, including the debugger, on your remote Linux, which is really cool. All right, so now if we continue running the program, we can disable our breakpoints, continue running. And we can open terminal to make sure that the open RCT2 CLI program is running, which it is. Another really cool feature of the remote SSH extension is that you can set up port forwarding. So to make sure that this works, like this server is up and running and we can actually play the game, I set up port forwarding and I'm going to run OpenRCT2 headless on my Linux VM and then connect that game server on my Mac OS. So in our build folder, we see the executable. We'll run that. We'll pass in the scenario files that are on my local VM, and then the headless flag. And you can see it says ready for clients. So now if I go to my Mac laptop again, or my Mac window of VS Code, and we can run the target that we've already built, the OpenRCT2 target, and this should launch the game as it did before. And now I can go to the third option and connect to a server. So I'm connecting to the server I have running on my Linux VM. And there you have it. So the point of connecting to this from the Mac is just to show you that you can successfully build this project on Linux the same way you would on Mac OS without changing anything about the configuration. You're using the manifest file, you're using CMake, you're using VS Code. And if you set your project up with CMake and VC package from the start, it's very easy for people to develop to that, like for that project on their machine. VS Code has CMake and VC package integration, creating an intuitive user experience for configuring, building, and debugging your C++ projects. Okay, so that was the first recommendation, which was setting up your project for cross-platform development. Now let's go into the second recommendation, which is using remote development containers. So for the first project, you still had to do some kind of configuration, right? You had to install VC package or have CMake installed on your machine. But what if I told you that if you add just 2 files to your project repository, that it could be run from any machine, regardless of the build tools or dependencies that are installed on that machine? So that's when a remote container comes in. So what is a development container? A remote development container is a piece of software that packages code and any dependencies that code needs to run, like runtime, operating system, tools, etc. And it packages all of that and runs your code, and it's completely separate from your host machine. So if you have like a version of a package installed in your container, it is unique to that container. A container is made from an image, and you use a Docker file to describe the contents of this image, such as the operating system, any build tools that you want to have installed. And then once that image is run, it becomes a container. So dev containers are especially helpful for instructors and students, let's say, because if you're an instructor and you have your starter code, you can add some dev container configuration files to this project repo on GitHub, share that with your students, and then they can clone that GitHub repo inside of a dev container. So it just sets up, let's say, like Ubuntu with CMake installed, Ninja installed, GDB installed, etc. And then it will, like your students can just run the program inside of that container regardless of the machine that they're using. And especially in today's remote world, you can't control what machines everyone has access to. So containers are a great option to create that consistent functional development environment for everyone, regardless of what resources they have at home. So in this demo, I'm going to create and share a container for C++ development in Visual Studio Code. I'm just going to use a sample Fibonacci program for this portion of the demo. This is just a personal GitHub repo that I've cloned onto my Mac laptop. So I've set this project up to use VC package and CMake and use that VC package manifest file. I've also added some doxed-in comments, which you can see the C++ extension displays those comments. You'll notice that there are error squiggles underneath the include paths. This is because I'm using the manifest file to install those dependencies, and I have not yet configured my project. So the VC package install command has not been run. But once I successfully configure my project, these dependencies listed in the JSON file will be installed and those error squiggles should go away. All right, so now let's configure and build and run the program locally to make sure everything works before setting it up in a container. So let's run cmake configure. You see it says running VC package install. So we've successfully configured and the error squiggles under the include paths have gone away. So now let's build our project. All right, successful build. Now we can run it. And I'll just run the project so we can see what the successful output would look like. Cool. So now let's say I'm an instructor, I want to share this starter code with my students with the dev container files that they need to run this code inside of a container. So they don't have to do any of that configuration themselves. I can use the remote containers extension to add development container configuration files to my project. And then let's select C++. So the remote containers extension will generate the dev container files that you need for C++ development. So the dev container.json file describes how to connect to your container and then what to do after you connect. So you can choose which VS Code extensions you want to have installed in that container. I'm going to add the CMake tools extension because we'll be using CMake tools to build this project. And now the Docker file, that describes what goes into this image. And the remote containers extension has provided a sample Docker file that installs useful things for C++ development because we had selected C++ development language. But I'm going to customize this Docker file so that it installs all of the dependencies that we need for our project. And when I say dependencies for our project, I don't mean project specific libraries, for example. I mean, we are installing some build tools like CMake, Ninja, GDB in that first run statement. And then in the second run statement, we're installing VC package because we're going to use VC package to install project specific dependencies. This way, if project dependencies change, the project changes, you don't actually need to update the Docker file as long as VC package is installed in the container. Installing VC package is simple, 3 steps: clone the GitHub repo, run the bootstrapper, and then run VC package integrate install so that you know what to set the CMake toolchain file path to. So now that we have our container files, let's open this project inside of a C++ development container. And we can do so by opening the command palette and then using the remote containers extension to open folder in container. So this is now setting up the container and creating the container based off of the contents that we defined in the dev container.json and the Docker file. And you can see like the CMake tools extension was successfully installed. We see all of those commands in the status bar. And then in the bottom left corner, you can see that we're developing inside of this dev container. So there's one more thing actually that we need to do to get this working inside of the dev container. We need to change the CMake toolchain file path because this was the file path that I used on my Mac when I initially created this repo. But we installed VC package in the root file system in the top level directory of our container. So we know what the toolchain file path will be. And we can confirm this by looking for VC package on this in this dev container. And yeah, there it is in the top level directory. All right, so at this point, we should be good to start configuring and building our project and make sure it runs successfully in this container. We'll remove our build folder so we can do a clean configure. Yeah, we have our CMake list, we have our main. And again, you see the include error squiggles because we haven't configured our project yet. So let's run CMake configure. And there you can see it's installing the packages using VC package that we need for this project. And it's using binary caching to optimize the speed of installation. Cool. So we've configured our project, build files have been generated. So now we can build our project. Successful build, let's run it. All right, cool. So now I have this program and dev container files so that people can run this program inside the container. Oh, it's also worth pointing out that the kits that we scanned for are the kits that are found inside of that dev container based off of the contents of the Docker file. But so now I have this working program with these dev container files, and I want to add these files to my GitHub repository so that I can share it with students, let's say, if I'm the instructor. So we will close our remote connection. And now I'm going to open this file again on my Mac, and I'm going to submit a pull request to GitHub from VS Code with these new dev container files. So first, let's create a new branch. And in the bottom left, we can switch to a new branch. We'll type add dev container files. And then you can see again in the bottom left that we're now on this new branch. And then to see what changes I've made to this repository, I can open the source control tab on the left and then add any changes. Like I can stage them to be committed. So let's go ahead and add any of the files that I changed. Let's add our Docker file and our dev container and our settings.json where we updated the CMake toolchain file path. And you can see my change log is cluttered with changes to my build folder. You can prevent that by adding a git ignore file. So let's add a message now to stage these changes, to commit these changes. And then by clicking that check mark, you've committed them. And now we can push these changes. If we click on the ellipses and then select pull push, and then we'll do push to origin. All right, so we've pushed these changes, and now I can use the GitHub pull request and issues extension to create a pull request and merge these changes into master. So we click the plus sign, we select the branch that we want to merge these changes into, and then select commit, and it's creating the pull request. All right, so it opens the pull request inside of VS Code, and you can interact with this pull request directly inside of VS Code the same way you would in the web browser on GitHub. And we see a list of pull requests. We see the ones that are created by me. You can actually change the pull requests that show up here by editing the queries yourself in the settings. And then you can look at the side-by-side comparison of the changes you've made for each file in this pull request. You can also look at the specific commits within a pull request down in the bottom. So going back to reviewing this PR, you can do things like leave a comment if you wanted to do that. You can add reviewers to this pull request. So if you click on that plus sign next to reviewers and then add the GitHub username of the person you want to add as a reviewer, you can add labels, and then you can merge the pull request. So I'm going to merge this pull request into master. There we go. Great. And now I'm going to copy the URL of my GitHub repo so I can show you how, if you were on the other end of this, let's say like you were the student and you wanted to run this project inside of a container, you could use the remote containers extension to add a new container and select clone repository in container, add the GitHub URL. And then this lets you use this container as your development environment in VS Code. So like if you were the student in that scenario, all you have to do is paste that URL and open it in a container, and it will, like, you'll be able to just build the program successfully and develop inside of this container. You don't need to do any other configuration because the container automatically installs any of those dependencies that you need. Like you can see here um, in the output that it installed the extensions that we wanted it to. So some takeaways from that demo is that it's very easy to create containers in VS Code. You just add two files, and the remote containers extension will add these files for you, knowing like based off of the programming language that you say you are developing in. You can develop inside a container using VS Code, so you still have access to the full feature set of VS Code, like editing and debugging. And it's easy to clone GitHub repositories inside of containers, eliminating all configuration. You don't even have to create the dev container files. And because of that, it's a great option for instructors and students, great option for collaborative development to ensure you have consistent environments across different machines. Okay, so we've talked about the first two recommendations. And at this point, you might be thinking, like, sure, I can set my project up for cross-platform development using CMake and VC package, or I can add dev container configuration files to it and get it set up to run in a container. But what if I didn't do either of those two things? I have a problem. I need help ASAP. I don't have time to make my project configurable on someone else's machine and help someone reproduce my issue on their machine. That's where LiveShare comes in. So, what's LiveShare? LiveShare enables you to view someone else's workspace in the context of your own editor, like your own instance of VS Code. So, as a host, you could start a LiveShare session, which will generate a URL that you send to whoever you want. And then anyone can join your session using that URL and see everything that you're seeing in VS Code. They can see that in their instance of VS Code as well. And not only can they see it, they can interact with it. They can navigate through your code base, use editing features, code navigation features like find all references, go to definition. You can even do a collaborative debugging session, and the guest doesn't even need to have the source code on their computer at all. They don't need to have the compiler, the debugger. They are able to co-edit and co-debug with you without having anything related to that project installed on their machine. So in this demo, I will start a live share collaboration session on my Windows laptop and then join it from my Mac laptop, and we'll do some editing, a collaborative debugging session. And for this demo, I'll be using SuperText, which is another open source CMake project. Okay, so this screen right here, this is my Windows laptop. And if I open the live share pane on the left, that arrow icon, and select Start Collaboration Session, this generates a URL and automatically copies it to my clipboard. So now if I send that URL out, anyone can join. So now this is my Mac laptop where I'm going to join this session. So I'll select join instead of start and then paste the URL that I was just sent here. And then it's starting to load SuperTux on the Mac laptop. So now we have a side-by-side view of what the host and what the guests are seeing. And so you can see the other person's cursor. And to start, the guests will navigate with the host. So if the host goes to a different source file, the guests will go with them until the guest starts navigating independently. And so here you see if I'm highlighting something on my Windows computer, I can see that on my Mac. And then vice versa is true. If I highlight something from Mac, that shows up on Windows as well. So you can see how the other person is interacting with the code. Okay, so now I've navigated to another file as the guest on my Mac laptop. And at this point, the host and the guest are navigating independently. You can see on Windows, we've switched to a new file, and on Mac, they stayed where they are. Okay, so let's check out some of the editing features that are available to the guest, such as find all references. So if I want to find all references of this mstate variable, I can select find all references. And when the C++ extension does the find all reference, it finds both confirmed and unconfirmed references for this variable. So here we see all of the confirmed references. If there were unconfirmed references, they would appear beneath that. And an unconfirmed reference basically means it's a text match, but not necessarily a semantic match. It could be like in an inactive code block or in a comment. So now as the guest, I can also rename the symbol. So let's say I want to rename this to end state. Then I can do a shift enter to preview the results. So this refactor preview pops up, and by default, all of the confirmed references are selected. And then you can unselect references, don't want to include them in your rename. So you can control what goes into this rename. When you're ready, then you can just click a check mark on the right or exit out, which is what I just did. So now we've seen how you can co-edit and navigate through the code. Let's start a collaborative debugging session. So going back to my Windows laptop, I'm going to go to my main.cpp file where I have a breakpoint set and use the CMake Tools extension to start a debugging session. So this will launch the debugger UI on both the Windows laptop and the Mac laptop. It's building the project first, so it's taking a second to build. And now we see it's launched on Windows. It'll be a second before it launches on Mac. There we have it. So as the guest, you can interact with the debugger yourself, like step through the code or set variable values. So let's say I wanted to either like set the variable value for this one. I could do that from the context menu, or you can add it to watch and add your own watch variables. And you can add breakpoints, disable breakpoints. You can really do everything with the debugger as the guest that you would as the host. So let's continue running the program. And then this should launch SuperTux, the game, on the Windows laptop. Yep, there it is. So some takeaways about LiveShare. It enables remote pair programming. so that you can still navigate independently through a code base. You can experience the host workspace in the context of your own editor, so you still have all of the preferences and settings that you've customized for your editor. You can use IntelliSense and refactoring and code navigation as the guest, even though you don't have any of the source files installed on or copied on your machine. And you can debug together. So it really navigates around a lot of the limitations that you have when you're just screen sharing, for example. When you're screen sharing, only one person, the person who's sharing their screen, can navigate through the code. And if you're watching someone share their screen, you're kind of just following along with the actions they're taking. But with live share, you can really co edit and co debug from your own machine, from your own house. So some conclusions from all of these demos are that CMake and VC Package set your project up for cross-platform development success, and dev containers, they eliminate the time spent setting up the environment so that people can quickly reproduce issues no matter what machine they're using. LiveShare is a great option for pair programming, and all of these extensions that I demoed for you today are included in the new C++ extension pack. So check that out if you want to play around with the extensions that I demoed today. And now to get into some exciting announcements. C++ in Visual Studio Code has reached version 1.0 today. During the time that you've been watching this talk, version 1.0 has been released. What does version 1.0 mean? Basically, the extension has been in preview for 4 years. And throughout these 4 years, we've worked with customers, and our customers have helped shape the direction of C++ development in Visual Studio Code by reporting bugs, reporting feature asks, and now that we have version 1.0, 1.0 delivers the top feature asks in high quality. So if you haven't tried the C++ extension in a while, now's the time to give it another shot. And while we're really excited about 1.0, it doesn't stop there. We're even more excited about what the future of C++ development and Visual Studio Code will bring. Some brand new features in 1.0 are support for Linux on ARM and ARM64. So you now have a first-class development experience for ARM and ARM64 in VS Code, complete with editing, IntelliSense, and remote build and debug. So you can develop for Raspberry Pi, your C++ applications for Raspberry Pi from Visual Studio Code. Another new feature in 1.0 is Visual C++ code formatting, which basically means all of the C++ code formatting features that are available today in Visual Studio are now supported in VS Code. And what's more is that VS Code has built-in editor config support for all of these new settings. So you can use an editor config file between VS and VS Code. It just allows for more customization with your code formatting. And then the third new thing that I have talked about throughout the demos today is the C++ extension pack. Check it out using that aka.ms link on the slide. It just contains a bunch of popular extensions that we believe will optimize your C++ development experience in Visual Studio Code. So give it a try, install the C++ extension pack. You can also check out our new Configure C++ IntelliSense in VS Code video tutorial. We know that configuring IntelliSense has not always been easy, so we've created this like 3-minute video tutorial to help you out. We also have Hello World build and debug tutorials for different compilers and platforms on our docs. You can use that aka.ms/cpp Hello World link to get there. So try it out. Let us know what you think. If you run into any issues or have any suggestions, please report them on our GitHub repository. We're happy to work with you and help shape the future of C++ development in VS Code. Some other announcements that we have and some things to look forward to are VC Package UI will be shipping in VS Code, so you'll be able to manage your libraries, your VC Package libraries from the editor, from VS Code itself, rather than just from the command line. And we have a Makefile Tools extension coming, which will be very similar in nature to the CMake Tools extension, where you can configure, build, and debug Makefile projects in Visual Studio Code. So I'm going to give you a sneak peek of what the VC Package UI in VS Code will look like. This demo was recorded by one of our developers, Daniel Shaw, on the VC Package team, and it's not yet in production. It's not even an insider's build, so things are subject to change before this is shipped to production. But just wanted to give you a sneak peek and get you excited about this because I'm certainly excited. So basically, we'll add some VC package settings to the C++ extension, where you can set your VC package preferred triplet and specify the path to the instance of VC package that you have on your machine. And then in this UI on the left, you can see the libraries that you have installed with that instance of VC package that you specified in settings. And you can install a new package just by clicking that plus sign and searching for it. And it'll install that package for the preferred triplet that you specified in the settings. So now if we refresh this view, we should see the FMT formatting library installed. And you notice that it created a vcpackage.json manifest file for our project with those dependencies. Now, if you remove a dependency and then refresh the view, you can see specifically like which dependencies are installed and in the manifest file. So that's why FMT has that little check mark next to it. And now let's include this library in our main.cpp program and use one of the functions from this library. Of results 42, and then output that string. Okay, so now we can build and run this program in VS Code, and we will use a build task. So this is not a CMake project. We're not using the CMake Tools extension. We're using VS Code build tasks, which is a task.json file. And this new command that was just selected is VC package setup task.json, which adds the include and linker flags that you need to be passed on the command line for VC package integration. So it'll automatically do that for you. And then we'll run the build task. Everything seems to be working. You can see the executables that were created appear in the project view on the left. And now we can start a debugging session. We'll just change the program name to be main, because that's the executable that we just created. And now we'll set a breakpoint, start debugging. So essentially, you'll be able to manage your VC package libraries and set up your build tasks so that it'll build using those VC package libraries automatically in Visual Studio Code. And one of the things that I showed you at the beginning of this demo is that we had to add the path to the VC package root in the settings. Down the road, we won't even have to do that. The C++ extension will be able to just find the VC package instance, but you could specify the root if you wanted to use a different instance of VC package instead. So thank you so much for listening to my talk. I hope you enjoy the rest of the conference. Once again, I'll say please visit our table at the expo hall to meet with the rest of the team, ask us any questions, discuss the latest announcements, like the V1 announcement for the C++ extension, and please take our survey if you want to be entered in a chance to win the Microsoft Flight Simulator. We have a bunch of other sessions throughout the week. So We have a few tomorrow on Tuesday, Wednesday, and Friday. So all throughout the week, you'll be able to attend sessions from the Visual C++ team. And looks like we have about 10 minutes left, so we can open up the floor to Q&A. Go over to Remo. All right, so I'm opening up the Q&A. Take a look at some of these questions. So the first one I see has the most upvotes is, how is the live share session encrypted? It's a great question. I actually don't have the context to answer that question for you right now, but if you ping me on Slack, I can get an answer for you, hopefully today, and just ask the live share team how the session is encrypted. What other extensions in VS Code would you recommend for C++ developers? Great question, because we just put together this extension pack. But one other extension that I'd recommend is the Doxygen documentation generator extension. So the C++ extension has support for displaying the documentation if you have the Doxygen comments in your code. And the Doxygen documentation generator extension generates the stubs for those comments automatically. So that's a useful one. We covered C++ extension and CMake tools extension today, GitHub pull requests and issues, the remote development extension pack is really useful. That contains the SSH extension that I showed you today, the containers extension that I showed you today, plus the WSL extension. There's also remote code spaces, which is really cool. You should definitely check out the talk that my colleague Nick will be giving on Wednesday about code spaces. And another extension I recommend is CMake extension. So what I showed you today is CMake tools, which has all of the configure, build, and debug support for CMake projects. The CMake extension has language support for CMake files themselves, which just makes it a little bit easier to read and edit those files. I see one question from Samantha. What common pitfalls do you see beginner C++ developers run into when using VS Code, specifically for collaborative development? Any advice on how to avoid those? Sure. So Visual Studio Code, like one of the great things about it is that it's super lightweight and customizable. So when you install Visual Studio Code out of the box, it doesn't have, like the C++ extension doesn't come with a compiler installed like a full IDE would. And that's the beauty of it. You can customize it to use the compiler or the debugger that you want, but it does require that you know how to install a compiler and how to install a debugger and make decisions about which ones you want to use. And our documentation has some great Hello World tutorials that walk you through everything from installing the extension, installing a compiler, setting up your build tasks so that VS Code will use that compiler to generate an executable, and things like that. So I think as a beginner, you might not realize all of the things that go into building a C++ project, like installing a compiler, setting up your build task to build it, setting up the debugger, launching the debugger, and things like that. It's not really just like you press a button and everything works. And I think that can, be difficult for beginners, but then once you get used to it, it's actually a great thing because it gives you all of this flexibility and customization. But I think avoiding those, one suggestion would be to check out our docs. Another suggestion would be to use CMake because the CMake tools extension abstracts you from a lot of that by finding the compilers on your computer itself, and you don't need to like edit the debug configuration in order to get the debugger to work. Just reading some of the other questions. Are you aware of intentions to group Git changes by directory to minimize such clutter a bit when there is no .git ignore? Um, so by directory, do you mean if you mean like subdirectories within the project? That's a good question. I'm not sure if there are intentions, but that is definitely a good feature request. So I don't work on that extension, but if you find that extension on GitHub and report an issue, then that would be a good way to track that feature request. Since we're talking about cross-platform development, what about automatically filling system include path in CPP properties.json? So that's a great question. I didn't really go into CPP properties.json in the session today because we were using CMake tools, and the CMake tools extension actually provides IntelliSense. You can set your IntelliSense configuration provider to be CMake tools. But if you are using CPP properties to define IntelliSense configuration, um, you can like define multiple IntelliSense configuration for different platforms so that it makes it really easy to switch between those configurations when you are switching the platform you're developing for. And you can configure IntelliSense for cross-compiling by changing the IntelliSense mode and the compiler path. It gives the extension enough information to emulate like that target architecture and give you the right IntelliSense for that target architecture. For include paths, as long as the compiler path property is automatically set, you should not need to change that setting at all unless your project needs to include header files that are not in your project directory or in the standard library header files for that compiler. Um, so it automatically does fill the include path with things that you need as long as the compiler path property is set. How does using live share with a partner affect the state of our Git repos? Um, so I'm not sure I understand this question fully, but if you're asking if, um, like if you are on a live share session and editing someone else's repository, like all of the changes that are being made are like for that person's repo on their machine. It doesn't affect anything that you have on your machine, if that answers the question. If that wasn't the question you were asking, feel free to post it again in the chat. Is there a plan to support select and set default CMake target? Oh, so when you're selecting your CMake target, is there a way to set that as the default target that you want to build or debug? That's a good question. I thought that the extension, like once you select that target, it'll use the most recently selected target. But I will confirm that. If you ping me on Slack, I can confirm that response with you. In terms of setting it as the default, I'm not sure if there's a way to do that currently, but I will look into that and I can, if you ping me on Slack, I can get you the answer. Or if you follow me on Twitter, I can post the answer to some of these questions on my Twitter as well. So some of the other questions are about live share. And I personally don't work on the live share extension. I don't have all of the answers for you. But what I can do is we can download these questions from the Q&A and then I can look into the answers to these questions and either post them on Twitter or if you ping me on Slack, I'll post them on Slack as well. All right. So I think we're just at about time. Um, I hope you enjoy the rest of the conference and are able to come to our table and check out some of the other sessions from the Visual C++ team.